In this first checkpoint exercise, we're told that the deli sells sandwiches for $5 each and bags of chips for $1 each, and Sandy has $10 to spend. The function y equals 10 minus 5x represents the number of bags of chips, y, and sandwiches x Sandy can buy. Graph the function and interpret the points graphed. So the first thing we want to do is we'll make a function table here for x and y. So x and y, and now we'll determine if x equals 0, if x equals 1, and if x equals 2, what y will equal. So if x equals 0, y equals 10 minus 5 times 0, which equals 10 minus 0, which is just 10. When x equals 1, y equals 10 minus 5 times 1, which equals 10 minus 5, which equals 5. And when x equals 2, y equals 10 minus 5 times 2, which equals 10 minus 10, which equals 0. So we'll plot those points, 0, 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 0, 10. There's our point 0, 10. We'll go ahead and label our axes, x and y. And remember, this is sandwiches. And this up here is chips. Now 1, 5. We'll go ahead and we'll use a scale of each one of these is 1/2. So 2 marks would be 2. In this direction, we already set to 1 mark is 1 unit. So our next point is 1, 5, so we'll go over to 1 and up 5. 1, 2, 3, 4, 5. And then 2 and 0. So if we're actually graphing the function itself, it's not just these points. Though these points are the only ones that would make sense, unless they offer selling half a bag of chips or half of a sandwich. So when we actually graph the function, we're looking at graphing the line that goes through these points. But what do these actual points mean? 0, 10, 1, 5, and 2, 0. Well, look at what the axes mean. Look at what direction we're going. Y means chips, and X means sandwiches. So what this means is when you purchase 0 sandwiches, Sandy can purchase 10 bags of chips. When she purchases 1 sandwich, that means she can purchase 5 bags of chips. And when she purchases 2 sandwiches, she has spent all of her $10 and she cannot purchase any chips. Now with number 2, we are told to graph y equals 3x plus 4 and make a function table before graphing. So I've already set up the function table and the graph. We'll go ahead and determine f of negative 2. So 3 times negative 2 plus 4. That equals negative 6 plus 4, which equals negative 2. So we'll plot the point negative 2, negative 2. When x equals negative 1, 3 times negative 1 plus 4, that equals negative 3 plus 4, which equals 1. So we'll plot the point negative 1, 1. When x equals 0, 3 times 0 plus 4, well, that just equals 0 plus 4, which equals 4. So we'll plot the point 0, 4. When x equals 1, 3 times 1 plus 4 equals 3 plus 4, which equals 7. So 1, 7. And then finally 3 times 2 plus 4 equals 6 plus 4, which equals 10. So 7, 8, 9, 10. 1, 2, right about here. Now since we aren't given specific points like with a relation, we're given that this is a function, and it's not discrete because it's just y equals 3x plus 4, and we should know that that represents a line, and there is the function graphed. Now with number 3, we are told that at a local pet store, small lizards cost $3 each, large lizards cost $5 each. Let x equal the number of small lizards, and y represent the number of large lizards. And we're told to determine a function of the number of large lizards you can purchase if you have $20. So if we're looking at the large lizards, y equals We're starting off with 20, so that would be our initial value. And then that's a matter of how many small are we purchasing. So y equals 20 minus 3x. Now that's how much money we're going to have left over. So what we want is 5y equals 20 minus 3x. Or actually, we could write this more appropriately in context as 3 times the number of small lizards purchased plus 5 times the number of large lizards purchased equals our total of $20. We could also go ahead and divide this into, divide both sides by 5, and we get y equals 20 divided by 5 is 4 minus 3/5 x. So essentially, if we look at either this equation, this function, or this equation for the function, we're going to have, if we don't purchase any small lizards, we're going to be able to purchase 4 large lizards, which makes sense because 5 times 4 equals 20. Technically, since it's asking for a function, this would be the most appropriate equation here.